So we're gonna do on some low how to do the transfer learning in 6 steps. Okay, so we have a 6 step. Okay, so the first is obtain the pre-trained model. Then you can create a base model. Remember the word base? Base is this one. This is a base. Okay, this is a base. Okay, so then you freeze the layer. Freeze. Okay, remember the freeze. So this is all about the freeze. So this is the freeze. Okay, the freeze all, freeze some. Like my Sarah said, you can freeze any one you like, unfreeze any component you like. All right, then add the new layers. So basically, this is again about the put the layer on that, because you unfreeze something, you have to put a new layer according what you need. Then you do the training as normal. Then you're gonna look at the accuracy, plotted the graph, and analyze the accuracy just like a normal way. Nothing changes here, and also nothing changes on training. Okay, so this one and this one basically nothing changing. It's the same thing. You have trained like before, like CNN, and you also have to analyze the accuracy. What the difference is between the first. Obtain the model. When you say obtain the model, basically you're gonna download the pre-trained model. You can download from internet. So in that case, you can download from you can have the VGG16 Inception, uh, MobileNet, okay, ResNet, and so on. So normally people will download from that model because they are trained in a good condition. You can also download from any others basically. So and basically you can download from any others, anything that has been pre-trained. So download, in other words, you load it into your system. So you load the model. Then for the CRIT-based model, then you can set a program to delete this one. Okay. In this case, I don't use a fully connected layer, so I'm gonna delete this one. Okay. When I delete this one, so this I'm gonna have the base model. So this is the base model. So I delete this one. So in case you delete this, then gonna be the base model gonna be different. But basically, you just delete. Normally, people delete this because these are the most changing thing, especially the label. You're gonna change the label 2, 3, from 10 to 3 or 4, and so on, and also the classification, because previously probably the original model has 2 layers. You need 3 more layers, or you need a small layers with 500 node or something like that. So basically, most people deleting this one. So create a base model. So this, the red color is the base model basically. Okay. Delete this one, you have left this one. So when you left this one, basically mean base model. Or basically you can delete this one only. This is remain the same, become the base model. Okay. All right. So there is 2 type of base model here. Okay. And then you can freeze the layer. So freeze the layer, basically you can, so since you delete this one, your classification is gone already now. No more classification. You have, so these are only this, that one. Okay. So these are this, the same thing. You have a base model now without the top. Then you can freeze all. Or you freeze this one. You can freeze this one and this one. Unfreeze this one. Or basically you can freeze anything you want, anything you like. You can unfreeze all basically. When you unfreeze all, mean that it is like scratch model. Okay, you're gonna train it probably a long time because you need to analyze from the beginning the weight, because you unfreeze all. The easiest way is you freeze all. If you unfreeze all, just like a scratch. You can freeze. Normally people freeze at the beginning or at the end or half of it, the first, second half, or the first half, or in the middle. You can try that. Okay, when you freeze and then let's run the accuracy. How does it perform? Does it give better accuracy and so on? Okay, so the freeze layer. So in this case, this one. Okay, so now these are become links. Okay, so this circle, basically the base model are now here. And again here you freeze. You can freeze all. Okay, or the same thing, you can freeze the first half, you can freeze the second half, and or you unfreeze this one and freeze the rest. It's up to you. Okay, so we're gonna set that, gonna freeze something. Okay, then after that you add layer. So here you got empty, so you add layer there. So in this case I put one layer and 500 node. Basically, example, I got one layer and 500 node, and I put another 2 layer here for label, because rambutan and whatever. If you got 3 label or 4, you just put it 4. Okay, different from this one. So this is many. Okay, so you get need to 2. Okay, and so on. So you in this case you add top layer, you add classifier layer. Okay, and you can also, if you like this is your base model. So this become the base model. In this case, you just put 2 label for the last output layer. Okay, so you see the difference. Or probably the third one, wearing this one, you can also add, we have 3. Okay, add classifier, we add new layer. What are new layer you add? Classifier layer. You can add classifier layer. You can add only label, or you can add another one block here. Okay, so you got 3 there. 3 type of layer you can add it. You can add that the whole classification layer from input to the output, or you just is simply add just a label layer, or you can add another block of convolutional. If you want to delete, you just go here, going back, and unfreeze or freeze. Okay, remember that. You don't delete, you just freeze or unfreeze. If you freeze, disable. Freeze and unfreeze is about wait, but if you don't want to do it, you just disable. You can disable. So here you just can disable. Okay, you can disable. False, you set to false. The convolutional block number 3 is false. So that's mean later we'll see it. So when false mean it is omitted. All right, then you go training as usual. This is nothing special. You just run through epoch from your data set, how many epoch you want, 1,000, 2,000, 500, and so on, and see. So when you running the training, it depends on this one. All freeze, if you have your block here many, if you freeze all, the training will be very quick, because it's just training this one only, the output layer. If you unfreeze all, and you put another new layer, so the training will be just like original one from the scratch. You're going to take 4-6 days in this case, if it is a big layer and convolutional block. Okay, and at the end is just analyze the accuracy. Okay, analyze the accuracy. All right, so let's digest this 1, 2, 3, 4, 5, 6. Okay, and this is a look straightforward. Okay, now let's move to the next slide. Okay, the first, we go to the first in detail. Obtain the pre-trained model from literature. So we go to the first. Okay, the first 1, 2, 3, 4, 5, 6. Number 1. Okay, so these are the available model you can download from the literature. And this model basically Rust provided for you. You just simply one code and download it, and easily you can load into your system. So basically, Inception is about Google, from Google, and VGG 1619 are coming from Oxford University, and ResNet, basically you got many ResNet here. They are coming from Microsoft. You see these three things, and this is the size you can download. Okay, and this size is including the weight. Downloading the weight is the most time consuming. Okay, because weight is million of weights. So weights are million, so downloading it quite take some time. In this case, a bit okay. Now you got 528 megabyte. Okay, it's quite big, you know. The big are consumed mostly on weight. There are several million of weight and bias to be downloaded with its value. So this is the performance. Okay, so it did the performance on ImageNet. Okay, let's look this. Okay, so this model basically has been trained on 1.4 million images with 1,000 classes. Okay, if you upload this one, okay, to your system, so you have transfer learning, your model has 1,000 label, and this model has been trained on 1.4 million images, less than that, I think 1 million or something. Okay, so when you have your model trained with this kind of data, it's good, you know, it is confident, robust enough, cover all of this thing. You don't have to think about is there sufficient images, which is in 1,000 classes. It's big, you know, 1,000 classes. We are talking about 2, 3, 10, 20. This is 1,000 classes. This is really a good model to download. And let's see some of the code, basically. Look at some of the architecture. Scroll down. Okay, so this is LINET. So let's look on the LINET. How many labels are there? And did he say something? LINET is 1998. Forget about it. 1998 is too long. Okay, they get 60,000 parameter width. Okay, AlexNet. AlexNet is from guy named Alex. Okay, and you can do your research on this. How can I come out with AlexNet? What are the criteria? So AlexNet have 1, 2, 3, 4, 5 blocks of convolutional, and you got 60 million of weight and bias, and it got this is only two label, and the last layer of classic top is 4,000 nodes neuron and 4,000 neuron. Okay, size is 224 and 224. So this is AlexNet. This is VGG16, the famous one that I use always referring about. So the image is 224. Basically, how many blocks they got? 1, 2, 3, 4, 5. 5 blocks. And you got one layer only, 4,006 for the neural network, and you got 1,000 classes. Okay, and this is the thing. You can download this model. It's been pre-trained with 130 million, and this is Inception, and so on. Okay, you can look and so on. Okay, so this is the Inception. Okay, so this is the Inception. Is a bit more from the Google again. Okay, so this is the I think this output is 1,000. Okay, and there are series of convolutional variation here. Okay, so you can see the REST and ResNet. Okay, so this is ResNet. They got a lot of convolutional block here. All right, and you can see ResNet and model and so on. Okay, you can study this one later on. Okay, okay, get back to this one. Okay, so this is the example. Okay, and this has been trained. You can download it to your system, and this is the size. Okay, don't worry about the size. Okay, it will always be downloaded. It's not much actually, and I think I'm not worried about accuracy here simply because this is a powerful model with been training 11 image and 1,000 classes. Pretty must be good. Okay. So if you got free time, design the convolutional neural network on your own and try train your CNN with this million of images with 1,000 classes and get the accuracy. And if your accuracy is better than this, you're gonna be at the top. Simply like that. Like what Oxford do, Google do. Google is it is VG16 is in the year of 2016, and Oxford as the champion. It's the best accuracy, 71. It beat the others. Then again, later on, this is 79. Google beat the Oxford VGG. Okay. The beginning, okay, I think this is the best one. 82, 96. So remember this, NASNet large. Okay. People seems don't know about this one, you know. They normally VGG16, Inception, NASNet, because this come later. Okay. All right. So this is the model you can download easily. All right. How do you download the model? So basically, you just to declare, first you have to declare this one, the library from Keras import ResNet. See, they got already a library called ResNet 50. Okay. Or you can write TensorFlow Keras application import ResNet 50. Also the same. Once you declare the libraries, you just simply can load the model just simply like this. Okay, simply like this. Okay, I think I got just let me show you something how to load the pre-trained model basically. Okay, now let's look on the slide just now. Okay, this one. Okay, so this exception, which is in all of this, Keras has created a library for you to use, so you don't have to headache your head. So you just use this library. So when you use this library, you just can declare model equal to ResNet 50 like this. So this is simple thing. So let's say let's look on how is it. Okay, like this is VGG16. Okay, let's connect it. Okay, so this is where you import. Remember? So this is library. Then if you want to download your model VGG16, you just write this one. So just click that one. All right. So this is you download to your system. So you're gonna download. When you put nothing here, the weight is not be downloaded. The weight is 0. It's only the architecture. If I put ImageNet here, ImageNet, okay. So basically, what it means is you're gonna download this. This is the ImageNet dataset, okay. You're gonna download all the weight from this model. Okay, you got it? So if you put ImageNet there, you're going to download sometime. So I don't do that. Otherwise, you're going to waiting for quite some time to download all the 160 million weights. So you can just simply model summary to look at your model. Okay, so you have download now your system VG616. Okay, you have download this model, but the weight is not downloaded because I don't have ImageNet. But in your case, always the ImageNet, so that the weight is bring, because we save the model and we save put ImageNet, so the weight is bring. In this case, the weight is initialized to 0. If you run this, basically you're gonna take some time because the weight I'm not downloaded. So you will see there, it is a block 1, this is a block 1, this is a block 2, block 3, block 4, block 5, and this is the flatten, this is the dense. You got two layer of neural network. Each layer has 4096 neuron. The second, you got 4000 neuron, and label, you got 1000 label. Altogether is 138 million of weights. In this case, non-trainable parameter is 0, because non-trainable is 0. So all has to be trained. The weight has to be trained. Okay, simply because see this one. I just put like this. If you want to download, if you want to put ImageNet here, then the weight will gonna be, the non-trainable parameter will be have numbers here. Okay, so this is how you download. So this is the VG16. Looks at the model. This is how you download, easily like that. Just in 3 seconds you have a VG16 model. Your assignment, you develop a CNN model. It takes, I think, a week or 2 weeks to design the model, to do the coding, you know. But in this case, you just download the model VG16, you get all the Oxford University. VGG16, let's look on VGG16, okay? All right, you see? How many blocks you got? 1, 2, 3, 4, 5. And then you got 4096. Let's look on ours. So you got how many there? 1, 2, 3, 4, and 5. Okay. All right. So back again on this slide. So remember, in your assignment, you have to put this ImageNet. So we download the weight. In this case, we don't download the weights. We set the weight is 0. So non-trainable is 0, because all the weight here must be trained. In this case, all the ImageNet, all the weight has been trained. So non-trainable will have a value there. So do remember this one. This one, okay? And you can go to this basically to get more detail about the things, okay? About crust, all right? Okay, remember this. This is the most best site that you can refer. So about crust and crust application, okay? And you see there, okay? You see the crust application, there are many things that you can, okay? If you press this one, you're gonna have this, okay? Now you see there, this, see this? So these are basically this one, okay? Remember this? I just, okay? Everyone? Okay? Just look at that, look at that. And so this is the important one. And then the best part of this site is they're gonna include top. Include top. What does it mean? Whether to include the fully connected layer at the top of the network. If you put true, means that the top not gonna be deleted. So if you put true, basically mean it is, if you put true, basically it is mean this one. This one, okay? The whole thing, this one. Everything is there, okay? True. All right, and okay? So weights. Okay, if you put none, mean that your weight will be random. ImageNet, pre-train on ImageNet. So the weight gonna be there. And so on. You can have a look on that. Classes, how many classes you want to have? Okay, so this is only specified when include top is true. Because if you got top is there, then you can set the weight. If you don't have the top, how can you set the label? Okay, you have, if like this, you can just set the top into 2. Okay, all right, and let's move here again. Okay, and okay, this is back again. Okay, remember this one. Okay, so this is the first part. The first part is obtain the pre-trained model, and this is the code. Okay, you just simply, how many line here? So simply, if I change this is okay. All right, just let's see what's it gonna be. What's the wrong there? You have to input the library. There you got. Okay. Okay, so this one I need to delete again. Okay, just running this. Okay. All right. Then you have download the ResNet. So if you run the model, you're going to have a ResNet, okay? So ResNet will be different then, okay? Everyone, you have to understand the architecture of the ResNet. So you got dense about 1000 and you don't have a classification layer here. After you average the pooling, you just go to classification. Okay, now the second part basically is create base model. Okay, the second base model like this. Okay, you just delete this one. So let's look on the, so create the base model. Remember, this is the base model and this is the top. So this is the base model. Delete the classifier. So the top will be deleted. So in this case, let's look on my, look at this one. This is how you create. Delete the classifier. Model VG16 include top equal to false. False mean the top layer will be deleted. Okay, I think the rest will be self-explanatory. Okay, let's look down there. Base model. So base model basically, okay, 16 include top false. Okay, so and then let's see this image, the same things. Okay, then just running this one. Okay, then if you run model summary, the classifier will be deleted. See, there is no classifier. Compared to this one, this is VG16 with the top you deleted. Let's look the original one. V16, okay, and you go run. Then you got model summary VGC16. Okay, so VGC16, if you remember, you got after flatten, you got a first layer 4000 nodes, second layer is 4000 node, you got 1000. So this is the classification layer top. But when you put top false, mean the top will be deleted. There is no more dense layer neural network. Now the third one. So this is retain the classifier. If you retain, you just say true. Okay. Now this one is false. When you got false, you don't have classifier layer. Label is not there, and so on. Okay. So when you put it through, you change it through, it will have there. Okay. Okay, we'll move forward. Okay, and okay, freeze the layer. Freeze the layer, you just simply put another word there. Base model trainable is false. False mean you're gonna freeze the whole thing. The base model gonna be false, the whole thing. Okay, so you just simply like, oh, so this is true. Okay, you see the true. So when you got true, the top is there. All right, the tops. You got two layers, hidden layer, and you got label. And when you freeze, you just put this. Now look, non-trainable parameter is 0, mean that you unfreeze. So all the weight are initialized to 0 and you're gonna train it again. When you trainable is false, mean you freeze all the parameter weights. So let's see this one. Okay, create the model summary. Now you will see this, the non-trainable is 0. Now the non-trainable is 138 million. So it saves time, you know. They're not gonna change the weights. And if you look at this VG16, how many parameters are there? VGG16. It saves a lot, you know, 1,138 million. They're gonna save a lot of how many days to training, because you don't have to change the weight. There, it's 138 million. So based on that, you can see that 138 million, almost the same. So all parameters are freeze, non-trainable. The weight is non-trainable, so it cannot be trained. It fixed. Okay, it's about 138 million. Okay, so that's easy, isn't it? And okay, let's look on freeze layer. So if you say freeze layer some convolutional layer, you just simply like this, okay? Included top false, in this case false, then you just can have a look like this, okay? So model layer block 1 convolutional 1, block 1 convolutional 1, trainable false. Make some layer only untrainable. So block cover 2. So basically block 1 convolutional 1, block 1 this one, okay? So this the trainable false, freeze, the rest unfreeze, okay? So you freeze this, the rest unfreeze. So see, block 2 convolutional 1, block 2 until convolutional 2. So until this one, okay? So if you running that, let's say it is true, okay, never mind, let it true, running it again, just then you can change this one, then you can have a model summary. You freeze some of the block, you freeze block 1 and block 2, the rest you unfreeze, okay? It become less the trainable parameter because only some are trainable, some are not. Okay, now let's move on the next slide. Okay, now add a new label. Basically, when you add a new label, it's just simply include top is true, classes is equal to 2. Okay, now let's move on this one. Add new layer. Okay, so the original layer, you got 1000. Remember this label, you got 1000 label. Okay, you got 2 layer on neural network and then you got 1000 label. Then you want to change it into 10. So I just put like this. We generate none and classes equal to 10. Okay, let's run this one. So model summary. If you run the model summary, then basically you're gonna have 10 there. Okay, 10 label. Then in case your rambutan, how many label you got? Who's rambutan? How many label you got? 4. Okay, Hairul 4. Okay, you just simply import the label, import VGG16, just change here to 4. People are using their own CNN. I'm using the pre-trained Google Oxford University VGG16. Which one is far more better? Me. Okay, 4. Now, just let's look and there you got 4 now. Khairul ready for you, this model for you. You just now, when this model ready for you, Khairul, you use the same wait you put ImageNet and freeze all freeze, then you can just make sure your data set prepare, splitting the image, testing, training, and so on. Then you just can copy paste the existing code, just running it. Use the existing code. All are the same thing. The training, the testing, the plotting, all are the same code. Okay. Also the data preparation also the same code. You just need to change a few things there. All are the same code. You don't have to remember. Just copy paste and change a bit. During training, model fit, model training, compile, you just copy paste and change a bit. The same as plotting the figure, you just copy paste and change a bit in there. Okay. And the important is the first step lah. Data preparation a bit quite some difficult because you need to splitting the image and do augmentation, and those are a bit more work than the others. Okay. Okay. Add new label. All right. Now the next slide is add the new classifier. Okay. So if you don't have classifier, you got false. Then you freeze. Okay. Then you have to add like this. If you want to add like this, so let's say you want to add one layer, 1024, and you got 10 label, you just simply put this. Okay. So you are adding your layers. Because the top include top false, they're gonna delete it. So you replace with this one. Okay. So let's look on some example here. Okay, in this case, add new layer is already class 4, Khairul punya tadi. Okay, now we put another one, code. Okay, top are false. False mean we delete the classifier. Okay, just run it. Okay, now just look at the model. Model summary. Okay, false mean the classifier is gone, deleted. Let's look on the things. Okay, there is none. Okay, labels none, hidden layer none, neural network none. Okay, now we run this one. We want to add. So since this is none, we want to put another new layer of our own. We're gonna have the first hidden layer is 1024. I'm gonna activation value, and flat is from the above one. And the output basically we have a 10 label because we want to 10 label. I won't put it here. 10 label model input. So we're gonna put some library there. See, model, dense, flatten. These all are the library so that you can just put one line there. So you put the library there, run the library, and then you add the new top. All right, just this one. Okay, you need to specify that one. Okay, just let's look on this one. Okay, code. Okay, let's run once again. Okay, all right, just run this one again. Okay, nothing's wrong. Since you have false the top layer, you need to specify the input of VG16, which is 24 by 24 by 3. 23 to 24 to 224 by 3. Okay, so that's mean. Okay, now let's look here. Okay, you don't have neural network here, no hidden layer, no label. Now we put another label here. This is a new label. The hidden layer, first hidden layer is 2024, and we got 10 label. Then you have a model summary. Let's look at the model summary. And there you got 10 label and 1024. Okay, so if Khairul want something else, so Khairul can say that my is 4. I want more layer. Okay, I want more layer. So it just simply can put another layer. Put another layer. So class 1, class 2. So this is supposed to be class 1. Okay, let's see like this. Okay, supposed to be like this. Is supposed to be class 2. Okay, and this is supposed to be class 3. Let's try this one. What happened? It's supposed to be class 3. Okay, class 1 flat, class 1 2 2 3 3. Okay, so Khairul want 3 layer here. So let's run. Okay, just let's look the model. Okay, and now Khairul got 4 label, and you got 3 layer. So 3 layer means that the original one is how many layer? The original one is about 2 layer. One is 4006, 4006. All right, we're gonna beat the VGG. You got 4000. I got 1000 here. I got 1024. You can change to 4000 or 6000. So it bigger than the VGC 16. Okay, and train will be the same thing. Okay, nothing special. You use the code as well in the training, CNN training.